Hello, my name is Kevin Postrike. Thank you for taking a few minutes to engage yourself into this demonstration of modern development experiences with Liberty and Java applications for rapid innovation. Before I get into the demonstration, allow me to introduce the demonstration and the value that Java developers will realize when developing Java-based cloud-native applications with WebSphere Liberty, regardless of whether developing using Liberty standalone configuration or in containers. With any modern development experience, developers' productivity is key. Leveraging developer tools and platforms that support a fast, iterative development process for Java applications with Liberty is instrumental. Developing Java-based cloud-native applications using Liberty Developer Mode provides a rapid inter-loop development cycle that's ideal for supporting lots of small, iterative changes very quickly, allowing the developer to just focus on the code and not such things as rebuilding, repackaging, and redeploying the application to test the application after every single code change. Liberty provides a feature called Developer Mode or Dev Mode. When you run Liberty in Dev Mode, you can rapidly code, deploy, test, and debug applications directly from your integrated development environment or IDE or your favorite text editor. You can enable Dev Mode to work with either Maven or Gradle build automation tools. Dev Mode is available as a goal in the Open Liberty Maven plugin or as a task of the Liberty Gradle plugin. It integrates a set of capabilities for Liberty so that you can edit and monitor your applications in real time without restarting your runtime server. Dev Mode is supported as a command line utility and as an extension in VS Code or IntelliJ integrated development environments or IDEs. The Open Liberty Tools extension for VS Code and IntelliJ integrate Dev Mode functions directly into your chosen IDE. After you install either of these extensions and enable either Maven or Gradle plugin, you can find your project name in the Liberty Dev dashboard window in the VS Code or IntelliJ IDE. You can access Dev Mode functions by right-clicking on the project name and selecting a command from the drop-down menu within your integrated development environment. With Dev Mode, you can quickly iterate on changes to your code and config via the hot deployment capabilities and get immediate feedback from the on-demand or automatic unit and integration test. You can also attach a debugger to step through the code at any time. Dev Mode integrates a set of capabilities for Liberty so that you can edit and monitor the applications in real time without restarting your server. Dev Mode addresses three primary focus areas: deploying changes, running tests, and debugging, while avoiding the time-consuming rebuild, repackage, and redeploy process, which is allowing developers to just focus on the code. If you're developing an application locally in a container, you can minimize differences between your development and production environments by running your containerized server in Dev Mode. With container support for Dev Mode, you can use the same Docker file for development and production. You use the same base image and customizations and specify the same configuration files in your Docker file that you use for your application in production. Dev Mode for containers supports the same rapid interloop development capabilities, supporting hot deploy of code changes into the container, testing, and debugging on the container. Dev Mode in container is supported in the command line utility and in the Open Liberty Tools extensions in VS Code and IntelliJ. Using Dev Mode for containers is very similar to using Dev Mode without containers. You start with the same Maven or Gradle projects and include the Maven or Gradle plugin. However, using Dev Mode with containers, you also need to provide a Docker file that you use to construct the container image. When using Maven, launching Dev Mode in containers uses the command maven liberty:-devc in order to run Liberty in a container, plus any optional parameters that are needed, such as the path to a Docker file or a Docker network to join. When using Gradle, launching Dev Mode in containers uses the command liberty:-devc to run Liberty in containers. Once the Dev Mode for containers is launched and the Liberty server is running in the container, the developer only needs to focus on the iterative code changes, which are hot deployed into the container, and running tests and debugging the code. Thanks to Dev Mode, all this is accomplished without rebuilding and redeploying the container while iterating on making code changes, testing, and debugging. In the demonstration, we'll highlight several valuable capabilities that developers will love that deliver increased productivity and improved developer experience. Let's face it, Developers just want to code and not be bogged down with time-consuming aspects of rebuilding, repackaging, and redeploying applications and configurations just to test their code changes. We will showcase dev mode from the command line utility, which can be used with any of your favorite editors or IDE for developing the code. Using Liberty and dev mode's hot deployment capabilities, we'll enhance the application by implementing an improved health check into the Liberty application, test the code changes, and run the application from a browser to validate the end user experience. Next, we'll explore dev mode and running JUnit tests and using the Open Liberty Tools extensions in VS Code. Then we'll showcase the simplicity of using Liberty dev mode in containers, followed by a quick summary and wrap up. Now, let's get started with the demonstration. This demonstration uses a sample application called Customer Order Service. It's a simple Java application that runs on WebSphere Liberty. The application has a web interface that displays a sample storefront as an electronic and movie depot. The catalog items and customer information are maintained in the backend database. The application database runs locally in a Docker container. The application comprises of multiple project modules, including the web front end, a web module, and a backend data access layer, an EJB module, and is packaged as a deployable EAR module. The sample application is a Maven-based project and therefore uses Maven to build and package the application artifacts. The Liberty Maven plugin is configured in the project to enable Liberty in dev mode.
Okay, as I start the demo, let me point out a couple of things. First, I've already downloaded all of the artifacts needed for the demonstration, included the application and source code. And I've already got Liberty installed in this environment. Alright, so the first thing I'll do is start Liberty in dev mode. And to do that, I need to navigate to the applications directory. I'm already navigated there, so let's take a look at what we have here. We notice that we have multiple modules that make up the application, as well as a high-level pom.xml file, which is the Maven configuration file. And we'll get into that a little bit more later. So we'll start by running Liberty in dev mode using the command line utility. Starting Liberty in dev mode, Maven goes off and builds the associated projects with this application and then starts the Liberty server. So this could take a couple of minutes. So while the application server is starting and the applications are starting, let's take a look at the high-level POM file and see why we're able to actually start Liberty in dev mode using that command line utility from Maven. As we talked about in the introduction, Maven projects are configured by pom.xml files, and at the root of our project we have a pom.xml file for the application. And here's where we define the plugin that's actually being used as part of the Liberty in dev mode. And so it's the Liberty Maven plugin. So adding this plugin into the stanza in our pom.xml file enables us to run Liberty in dev mode. In this pom.xml file, you also notice that it has inclusions of additional modules. So this is a multi-module application, and the modules include an EJB module for the backend data access layer, the web module for the front end, and an EAR module for packaging the application as an EAR, deploying it to the Liberty runtime server. So by now the application started in Liberty, and we see in the log file for Liberty at the console that our customer order services application EAR file has started on the server, and it's given us a URL to be able to access that server locally. So I have this bookmarked on a browser, so I'll just go ahead and try the application from the browser. And we'll see that the application's front end is called the Electronic and Movie Depot. And so when I try to launch this application, you'll notice that I'm getting an error on the application itself, in that it's not able to display and load the catalog from the database. And without going into a lot of detail, if we just look at the messages that are in the Liberty log file, we can see in fact that we're getting some messages that refuse connection to the database. This is expected at this point because the application database, which is running in a Docker container, is currently not running. So this is by design for this demonstration for the scenario that we're going to explore. So the developer scenario that we want to explore in this demonstration will help highlight some of the benefits that we get from using Liberty in dev mode. So the scenario is this. The business has asked us to make improvements to the application so that we can implement a more suitable health check to verify the readiness and liveliness of the application. So in this case, the application is up, but it's really not ready or available because it doesn't have access to the backend database. So to do that, we're going to use Liberty in dev mode. We're going to implement an updated health check using some MicroProfile APIs and the MP Health feature in WebSphere Liberty. So the requirement that we receive from the business is that the improved health check that we implement should validate the application is running and also validate that the application can successfully access the application database and retrieve contents from the database. If the conditions are met, then the health check readiness state should indicate that the application is up. Otherwise, the readiness state should indicate that it's down. So we have some work to do in this scenario, so let's roll up our sleeves and get started. The next thing I want to point out is that the application does currently have a health check included with the application, and I'll explain how this happened in just a second. But in this case, the health check is pretty basic. As long as I can hit the health endpoint of the application, then it's going to indicate that the readiness state is up and the liveliness state is up. So clearly that's not suitable because our application is really not ready because we can't access the database. The health endpoint is enabled through the MP Health feature in WebSphere Liberty. And so I've just launched VS Code so that we can look at some of the source files and application files and configuration files as we go through the demonstration. First, let's take a look at the server.xml file. You'll notice that we have several files for our server configuration in this case. We have the server configuration in the server.xml file that defines some of the high-level information such as the core features of the application that it's needed to run, the ports in which we're going to access the application, and the application itself as installed into the Liberty server. And as well as this application has some security enabled so that only authenticated users can log in and see the catalog and order stuff using the application. But the MicroProfile XML, which is included in the server.xml, is where we've defined some of additional features for the MicroProfile APIs that we might use in the application. The one of particular importance for this scenario is the MP Health 2.1 feature, which enables that health endpoint that we just looked at a minute ago. So we know we need to start the database in order to have the application run. I'm going to explore the code that we're going to use as an updated readiness check, but let's go ahead and start the database and we'll explore that while the database is starting up. And as I mentioned, the application database is running in a Docker container on the local system. So the container is up, but it'll take a minute or two for the actual database to come up and be active, and we'll come back to that in just a couple of minutes. So at this point, as a developer, we would implement an updated health check based on the requirements that the business gave us. So what I've done is I've included a script that's just going to update the readiness check for us by running the update readiness check shell script. So that script ran and updated the source code that's in the project, and as that source code got updated, you might have missed it, but the Liberty server noticed that those changes took place and detected those changes and actually redeployed or refreshed the application that's running in the Liberty server without us having to do anything. So now I have the code, updated health check code running, and we'll look at that in a few minutes. But let's take a high-level view of what that health check code is doing, right, to see if it meets our requirements. So basically the whole health check code that I just copied into our project tries to look up the OrderDB database from the naming service, right? The OrderDB is our application database, and it tries to connect to the database. And if it can get connected to the database, it runs a query on the database and counts the number of records or rows that comes back from that query. And if we get some records back from the query, then the readiness check should pass. And if we don't get any records back from the query, or we couldn't connect to the database and the result says null, then the health check should fail. Okay? So I don't want to highlight too much of the code, but let's take a peek at what that code looks like inside the project that got copied in here. So this is the readiness check, and I'm not going to bore you with all the details about the code that's implemented and all that good stuff, but let's just highlight a couple of things. First, there's the code that connects to the database and runs the query. But at the end, what I wanted to point out is this. So we've got those records from the database, we put them into a hash map, and if there's records in the hash map, or if there's elements in the hash map, then the health check is going to say that the order database is up, and it's going to list a number of product entries that it found from the database. And if it can't, then it's going to indicate that the database is down and you need to start the database. So we've already started the database, so that's good news. And because we've implemented an updated health check code in our project, and Liberty's dynamically picked up the changes in the runtime, we can do a couple of things to test our code and our new health check without having to do anything such as restarting the server or restarting the application. So let's return to the browser, and let's just hit our endpoint again and see if it reports back updates to the health check based on our ability to contact the database. So what you now see is that our health check's been updated with the new code, and because our database is running and it's been able to fetch 8 records from the database, then we indicate that the readiness of our application is up. Consequently, because our status is up, then we should be able to refresh our application and see that the application is working and connected to the database and pulled the catalog from the database. So what we've seen is that we can quickly update our code, test our changes without having to worry ourselves with repackaging and redeploying applications to the runtime. So as you can see, this is really benefiting our developers with increased productivity as they develop their application and test their changes. So we've been running Liberty in dev mode from the command line utility, but we can also run Liberty dev mode within common IDE such as VS Code and IntelliJ. So let's get out of the command line utility and let's experience Liberty dev mode within the VS Code environment. Okay, so this is a common IDE that developers would use today. In order to use Liberty in dev mode in VS Code, we need to have an extension installed for the Open Liberty tools. So let's take a quick peek at that before we get started using the environment. And so what you'll notice is the extensions that I have installed includes the Open Liberty tools, and just by looking at the high level information, we can kind of drill down and see that it has certain features and it's supported by the Liberty Maven plugin, which is what we have in our project already, and certain commands that for Liberty and testing and that are supported using this particular plugin, such as starting Liberty server, starting it with command line with additional arguments, and starting it in a container, stopping the application server, running tests, and viewing test reports. So those are the kinds of things that are supported in the Open Liberty tools for Liberty in dev mode in VS Code or IntelliJ. There are some dependencies. So the dependency for this plugin requires the tools for MicroProfile to be installed as an extension into VS Code as well. And as such, we've installed that extension as well in our environment. So that's just to show you that what we had to do in order to use the capabilities that I'm going to show you next in this portion of the demo. So by adding that plugin, what's happened is it's included this Liberty Dev dashboard inside of our project. So remember, I launched VS Code at the root directory of our project, so it recognizes all of our application code, and it recognizes that I have a Liberty server. In this case, the Liberty server that we're going to work with is called Project. And if I right click on the project, then you can see the available options that we just reviewed in the documentation, that I can start the Liberty server in dev mode directly from the tool. So it takes just a second, as it did from the command line, to start the application server, do the Maven builds and all that good stuff. And after a minute or so, the application server will be up and running, as indicated here that our application is actually running and it's available in our application server. So from the dev mode inside of our IDE, I can run the application again, and you see it's still hitting the same endpoint and the application is still working, but we're running Liberty from within the IDE. So we've already explored some of the hot code deployment capabilities with using Liberty in dev mode. It also works not only with Java components, but also non-Java components. So for example, we can continue doing some minor development within our application directly from the IDE. So maybe in this case, we want to make an update to the application where we'll make a simple change to an HTML file. So in this case, we have title for the application. It's just called Electronic and Movie Depot. Maybe I just want to make a simple change and rename this to Electronic and Movie Zone. Okay. So if I save that HTML file, again, Liberty goes off and recognizes those changes and immediately makes that available. So if I refresh my application, then immediately those changes are detected and our web page is now reflected as Electronic and Movie Zone. So in addition to just developing the code, we also have the ability to do integrated tests and unit tests. So in this case, what I've done is I have implemented a JUnit test that tests the health endpoint. So we saw that the health endpoint ran with our updated code, and the server is reflected as being up if we can access the database and get records back from the database. So I've implemented a JUnit test that does just that. And from the IDE, we can run those tests. I'm going to expand this just a second here so you can see that it goes through looking for tests within each of the modules. And it found one JUnit test to run, and that test was successful. So all that test did was just invoke the health endpoint that we ran from a browser earlier. The test reports ideally would be viewable right from the options here to be able to view the integrated test and the JUnit test reports. But unfortunately, at the time of this demo, there's a little glitch viewing those test reports using multi-module applications, which is the case for this particular demonstration. So instead, what I can do is just kind of show you the reports that got generated within the project. And in this case, the report is the sample cause test text file, in which case is showing you that we ran a set of tests from the sample cause test and we had one test running. So it reports the same information you saw in the console, but as a text file. So the cool thing in Liberty Dev Mode is that you could rerun those tests at any time just by pressing the Enter key within the terminal window, and it'll rerun those tests at any time. So if you're making code changes and you want to rerun your tests as you're making code changes, you can get some quick validation just by running those unit tests or integration tests right from the IDE. So as I mentioned, the unit test simply invokes a health endpoint and validates that our application is running and connect to the database. So if I stop the database, then the test presumably would fail. All right, so the order database for the application is now down. And so if I go back and I rerun my application, for example, you see that I get an error on the application. If I rerun my health check, it's going to indicate that my application is down. And if I go back and rerun my unit tests from the IDE, then you'll see that it reports that I got a failure in my test. And what we're looking for in the JUnit test is a HTTP response code of 200, which is what the normal response code is from a health check. And if the health check fails, then it returns an HTTP status code of 503. So in this case, it's telling me I got an error. I invoked the health check. I was expecting a 200, but I got a 503, indicating that the health check failed. So that's an example of using Liberty in dev mode inside of the integrated development environment, in this case VS Code. Let's go ahead and stop the Liberty server that's running in the standalone mode, and let's explore just for a couple of minutes about how we can use Liberty in dev mode in containers. so that the Liberty is actually running in a Docker container. So I stopped Liberty in dev mode. I do need to go and restart the database. Go ahead and kick that off. So in VS Code or from the command line utility, you can run Liberty dev mode in containers. So I'm just going to stay in VS Code and do it. So in this case, if I click on project, start indicates that I'm going to start it in just Liberty in standalone mode, or I can start in a container. And I can click this to start Liberty dev mode in a container if I don't need any additional parameters to pass along to the command to start in a container. If I need to pass command line arguments to start it in a container, then I would use the start ... and then pass in those parameters. And so in this case, I need to pass in some parameters to be able to run our application in a container. And the parameters I'm passing in is basically two things. I'm pointing to a non-default directory location for my Docker file, which is needed to run the application in Docker in containers. And I'm passing in the Docker network that I want the application to connect to. And this is the same Docker network that the DB2 is running in a container. So in order for two Docker containers to talk to one another, in this case the application contact the database, they need to be in the same Docker network. So in this case, I'll go ahead and start the application up in a container in dev mode. So this takes a couple of minutes for the Docker file to get the image up, pull the image, create the containers, put the application in the container and start the container. So this will take a couple of minutes, and I'll pause while this is starting. Okay, so it appears that the application server and the application is running in a container. Let's go ahead and validate that real quick by trying to access the application. And the application seems to work. I'm able to run my application, connect to the database, and pull back the catalog. Using Liberty in dev mode in containers is just as efficient with its hot code deploy as it is without containers. So for example, if I go back to make a code change to, let's say, my HTML, and I change the title back to Electronic and Movie Depot and save those changes, the hot deploy mechanism takes effect into the container, and then I can rerun my application and see that those changes are picked up immediately inside of the container without having to rebuild the entire Docker image, redeploy the image, and all that good stuff. It's just a hot deploy. Unit test works the same way. If I want to run my JUnit test, then I can just go ahead and trigger the test from the IDE or click the enter key inside of the console here, and those unit tests will run. So everything is identically the same running in containers or outside of containers using Liberty for dev mode, whether you're running from Liberty in dev mode from the command line utility, or in your favorite IDE such as VS Code, IntelliJ, or your favorite editor with Liberty in dev mode. So that's pretty much all I wanted to cover in this demonstration. So thank you so much for your attention.